So hello everyone and welcome to this North Carolina Botanical Garden online program. So Craig Blackmar is an industry veteran who began his career in 1988. He's an ISA board certified master arborist with the tree risk assessment qualification and an illustrious member of the sales team at Leaf and Limb. His superpower is plant health care. If you have trees or shrubs that are in need of help, Craig is your expert. He's also a skillful musician. He makes the mandolin purr like a kitten with catnip. He also plays the guitar and saxophone, and one of his favorite quotes is, "All music is folk music because it's played by folks," by Jerome Garcia. So Craig, I'm going to hand off to you.
All right. Thank you, Joanna. And thank you all for being here this morning. I'm really excited to have a nice, relatively small group. This should allow us to go through this presentation more like a class and less like just a presentation, as it were. Well, I'll stop periodically throughout and take questions and hopefully give you all something good to take away with you today. As Joanna said, I am a board certified master arborist, but above that, I am a tree ecologist. And tree ecologists care for trees because we love our planet. Our mission is to plant, preserve, and promote trees in a manner that's of maximum benefit to all members of the ecosystem. And nice thing about being a tree ecologist is anyone can be a tree ecologist. And I'll tell you guys more about that later, but it's really about educating people about trees and our environment. I'll say I have a favorite tree. My favorite tree is the white oak, in particular, the swamp white oak. A white oak can serve as habitat and a food source for more than 50 different types of caterpillars. It's a food source for multiple vertebrates like squirrels, chipmunks, raccoons, deer, wild turkey. Can serve as a home for many of these animals as well, possums, raccoons, squirrels, etc., as well as serving as a food source and a home for thousands, and if not maybe even millions of different microscopic organisms. We have a program at Leaf and Limb we call Project Pando, which is all about planting native species of tree from seed and seedling for the purpose of planting in a public space. And we call this program Project Pando, which is named after the Pando, which is a community of quaking aspens out in Utah. And it's multiple acres of trees that all share one communal root system. And to us, that says community. I'll tell you a little bit about this presentation. What I'm going to give you guys today is just some really simple tips on how you can easily best care for your trees, starting from the time of planting. Try to keep this really basic so that it's very understandable and something that you can apply in your very own landscape. This presentation today is actually a companion presentation for another presentation that we have called How Trees Can Save the Planet and What You Can Do to Help. And if you're interested in that, one of my colleagues, Basil Camus, will be giving that presentation as a lunch and learn coming up in the future. I think you can find that on the Botanical Gardens website. Anyway, so without any further ado, I will get started. I will tell you, I'm going to share my screen. I have a PowerPoint presentation. From time to time, I will stop and shift out of that screen and show some videos. So, all right, the first tip is about planting trees. When you go to plant a tree, it's a good idea to have a goal in mind that, when you choose your tree for planting, is this tree for shade? Is it for beauty? Is it to hide your neighbor's ugly house? Whatever it might be, you should have some sort of a goal in mind. And then pick out the species of tree that you're going to plant. And it's very important that you understand the tree's full potential. How big is this tree going to get? How much root space is it going to take up? And assess your site before you choose your plant so that you get the right one and don't have any regrets later. Like these folks should. This tree, when it was really small, seemed like it probably had plenty of space in that little, what looks like about maybe a 5 or 6 by 6 area of soil. But you can see what kind of problems that's causing for that tree today. So doing a little bit of research ahead of time and learning everything you can about the given species of tree and what it's going to require will help you to choose the right tree for the right place. The biggest mistake I see people make on a regular basis is just the wrong tree in the wrong place. So now there's the actual job of planting a tree. I'll back up a little bit from this screen because it doesn't cover this, but to plant a tree, you have to dig a hole. And it's important that you dig the hole as large as you can, just to make it a little easier in the beginning for that tree to actually get its roots in the ground. A good recommendation is to dig your hole 2 to 3 times the size of the root ball of the tree. So let's say you've got a tree that's in a pot, a container with a 12-inch diameter. You should dig your hole 24 to 36 inches wide. And that way, once you put that tree in the hole and you start filling loosely with the soil that you took out of the hole, it'll give the tree a chance to get its roots into that new loose soil. And we're talking here about root collars. The root collar is basically a transition zone. That's where the trunk of the tree becomes the root system. And it should look somewhat like a flare outward, and you'll have the beginnings of the origins of the root system, what we call the buttress roots. That should be sitting at or above grade. And I'm going to show you guys a little video.
The second mistake I see is burying the root collar. Let me tell you what a root collar is. It's a really important term. The root collar is the base of the trunk before it disappears to roots. So it is literally a flare. Some people call it the root flare, root collar, same thing. You can't bury that. There's 2 typical ways people bury that root collar. Either they plant too deep, so you need to make sure that flare is at grade or just above grade, or some people will actually pile mulch on the base of the trunk. Don't do that. Both of those things will kill the tree over time.
So the root collar is, as I said, it's that transition zone where the trunk becomes the root system. And in nature, that will always be found right at or above grade. So if we take a walk out into the forest, you'll see this on all of the trees growing there. Even under all of the accumulation of leaf litter and everything else in the forest, that flare will always be really visible and pronounced. In nature, it is designed to stay above ground and to be dry. And the big mistake people make is to bury and cover that up.
You've probably seen this in the suburban landscape. This is what we call a mulch volcano. It looks great, but it's actually very harmful to the tree. Different parts of the tree are designed to perform different functions. The roots, for example, they are underground, they stay moist, they absorb water. The trunk is designed to grow above ground where it's supposed to stay dry. But having this mulch piled around the base of the tree constantly means that the cells of the trunk stay oversaturated. This causes damage to the cells, which means they're not able to perform their duties, which means the overall health of the tree begins to decline. In addition, the mulch volcano provides an excellent place for new roots to grow. They begin growing round and round the trunk of the tree. Over time, this leads to girdling. Girdling roots will quite literally strangle a tree. This may sound bad, but the story actually gets worse. As the health of the tree declines, it becomes more susceptible to attack from pests and disease. To give an analogy, it's much like the human immune system. As your immune system becomes weaker, you become more susceptible to the cold, to the flu, and to other sicknesses. But the good news is, this is a problem that we can fix. Well, the mulch volcano is gone and the trunk is clear of dirt and debris. There's no longer any opportunity for the roots to grow around the trunk. And we've got exactly what we want, which is we have a nice, well-developed root flare at the base of the trunk. The root flare is where the trunk spreads out before becoming roots that disappear underground. That's exactly what we're going for.
So hopefully everybody saw that finished product. And the interesting thing is, had the person that planted that tree taken the time to actually excavate that root collar with their fingers and hands when they took it out of the pot and properly planted it at the right grade, that never would have been necessary. And you could see all the roots that were pruned off that tree. Left alone, that tree certainly never would have lived to its potential. I often see trees in the landscape, and the first thing I might notice is there's a lot of dieback in the crown, a lot of dead branches, tips of branches, maybe infested with insects and other problems. But in looking at it, when I see the buried root collar, that's the beginning of all those problems. As Basil was saying, it's the underlying condition that then leaves the tree susceptible to so many other problems. And if we correct that at the time of planting, the tree stands a real good chance of living to its full potential. So we recommend always planting native, or what's called near native species. A true native species would be a species that is native to the area in which you live. A near native might be something that's native to another part of the eastern United States, but not necessarily found right here in the triangle. But that's still going to be a better suited species than something that, say, came from Asia. Don't get me wrong, there is a place in the landscape for introduced species, but they don't have any real ecological value in that they're not providing the proper food source for our pollinators and our birds, our other beneficial insects, our animals, everything else. A good example, they may only be providing aesthetic benefits. And again, there's nothing wrong with that. Japanese maple is a perfect example. I love the Japanese maples. And there's hundreds and hundreds of different varieties, and they have their place. And sometimes it's the perfect plant to put in the landscape for a nice focal point. You just have to understand that it is not really providing any benefit to the ecosystem there. But again, is providing benefit to humans, and we are part of the ecosystem in that, it's providing us with that beauty. Here's a link, a couple of links for some lists of native plants for our area. The first one up top is from our website, and we share a PDF there with a really good list of really good beneficial native plants. And then the other one's from the Worldwide National Wildlife Federation, and that's a pretty cool interactive plant finder where you can type in your location and then it'll automatically generate a list of plants native to your area. And then the hard part is then finding some of those plants in your local nurseries. I've found that there just aren't enough native nurseries and or nurseries that have enough or a large enough variety of native plants, but there are some great ones out there. A good place to find these is when they have plant sales at places like the Botanical Gardens or the Ralston Arboretum, Duke Gardens, great sources for native plants. Now back to mulch. We recommend using arborist wood chips. And there's many reasons for that. And one of the easiest ones for most people to grasp is normally you can get wood chips for free. And that's a win for everybody. Seeing tree crews working in your neighborhood and asking them, hey, what are you going to do with those wood chips? They've got to take them somewhere, and most folks are willing to give them away. Good reason for using the wood chips is in the wood chips, you have all of the components of a tree that have been chipped up. You've got leaves, you've got twigs, you got branches, even trunks, and you have all these different components. And when you put them out in your landscape as soil, they will be acted upon by many different types of decay fungi, and which will start the decomposition process and breaking those down and essentially turning them into topsoil. And so if you think about your mulch as food for your soil, by using wood chips rather than a triple shredded or a single source mulch, you're giving your soil more of a balanced diet, as it were. And mulch essentially does three things. It helps to hold moisture and manage water, cut down on competition from weeds, and then most importantly, what I was just talking about is feeding the soil. It essentially feeds all those microbes. So if you're using something like a triple shredded mulch, over time, what will happen as the rain beats down on that mulch is it becomes naturally compacted and can become what we call hydrophobic, where instead of water permeating down through the mulch, it starts to just run off, and it will build this mat on top of the ground and becomes counterproductive. I'm going to show a video again.
One big thing you've got to watch out for, especially with a triple shred product, is it becomes hydrophobic over time. And this means that on the top of the mulch, it begins repelling water. If this happens, you're not getting water in your root system. The tree has to have water. And now mulch actually becomes an enemy of your tree. It's causing a net negative impact to your tree. So what you've got to watch for, if you see water running off the top of the mulch when you're watering, or if you notice that the top of the triple shred is looking crusty, go check. Turn it over, poke your finger through. Is it soft and loamy? Can you turn the mulch over? Or it has a hard crust developed on the top? If you've got a hard crust on the top, you've got to turn that mulch over. The easiest way to do this is with a tool called the potato hoe. It has prongs that point down. Very easy way just to dig, pull, very easy way to turn the mulch over. If you're using a triple shred mulch on one of your properties or in your community, rest assured it becomes hydrophobic. You need to schedule the mulch to be turned over at least once or twice a year.
All right, hopefully that made sense. Back to the wood chips, because the wood chips have all those different components of the tree in there, and there are lots of different sized pieces and particles. They tend to stay more coarse and have a lot more airspace. And for that alone, it helps keep them from becoming compacted and creating that hydrophobic condition in your mulch. All right. Leave the leaves. If nothing else, that's often my motto. Everybody goes to all this work in the fall to clean their landscapes and rid them of leaves. And when they do that, you're actually ridding yourself of future topsoil. You could take a walk in the forest, and there's a nice layer of leaf litter there. But the forest may be 100 years old, and there's not 100 years of leaves there. If there were, they'd be up to the sky, but they're not. They decompose really really fast and basically turn into topsoil, feeding all the microbes and enriching the soil. So as a general rule, we say leave the leaves. Now, if you have nice lawn areas and you want to clear the lawn and the driveway and everything else, well, you can move the leaves around, but leave them in the landscape underneath your trees and shrubs. It's the best source of nutrition for your plants. Basically, trees go through what we call nutrition cycling. So the plant's making energy, is pulling nutrients up from the ground, using that as food for energy to feed the photosynthesis process, in which the tree converts carbon from the air and the nutrients from the soil and creates new energy in the tree in the form of sugars and starches, which it then uses for growth, to fight off disease, insects. It sends it back down at the end of the year, puts that into root growth, excretes what it doesn't need, feeding the bacterium and the fungi in the soil, and then eventually sheds the leaves. And then there's still nutrients in those leaves, which then decompose and then continue to feed the microbes in the soil. And then it all goes back, and then the tree takes them back up again. And it goes on and on ad infinitum. Fertilizers. We often use a term, I've heard it said many times, traditional fertilizers. And we think of traditional chemical fertilizers, but the sad part of that is that those traditions in those traditional fertilizers only began during the Industrial Revolution. Prior to that, everyone was using natural fertilizers, whether it was manure, compost, mulch, et cetera, et cetera. But with the advent of the chemical industries and adding that into agriculture, people started using these bagged synthetic chemical fertilizers. And in general, they're bad. They can create situations with your trees where your plant may become dependent on a artificial source of nitrogen in the form of a fertilizer, wherein had you just been leaving the leaves and allowing nutrients to cycle in the environment, the plants will get everything they need. A good example of that would be, go into the forest. Nobody is fertilizing those trees in the forest, and yet they're all perfectly healthy. I would say more healthy than the trees and shrubs in the landscape environment. And so as a general rule, we say, not to use those chemical fertilizers. They're bad for other reasons. One, nitrogen and phosphorus will leach out, float downstream, get into our water sources, harming fish and other animals. Excuse me. One of the biggest problems with chemical fertilizers is that the nitrogen source is often urea, and as a result, they're very high in salt. And salt and microbes generally do not get along. It can actually kill the beneficial mycorrhizal fungus in the soil, as well as other bacterium and fungi are pretty much repelled from salt. Let's see, I'm going to show you guys another video here.
Traditional fertilizers generate all sorts of problems. They can undermine the stability of your tree. They destroy the relationship between a tree and its beneficial mycorrhizal fungi. They pollute our streams, killing fish and other wildlife. There are some good fertilizer products available, but they are the ones that are focusing on enhancing biology, not on chemical inputs. So you want to look for products that have little to no nitrogen, no phosphorus, beneficial microbes, so those are fungi, bacteria, and then organic matter. Typically, the organic matter is going to be kelp, manure, yucca plant, these sorts of things. Once again, the key is to focus on the biology, the living component within the soil. If that's right, if that's healthy, your tree will receive all the nutrients that it ever needs. Healthy biology is the foundation for healthy soil, is the foundation for healthy trees. If you take just one thing away from today, remember, it's all about biology, not chemistry.
In the landscape, we've kind of fallen victim, and this is definitely true for commercial agriculture, of using chemicals. And when we start adding chemicals to the soil, one, we can start creating dependencies in our plants for those chemicals. But every time you add chemicals to any given situation, been my experience, it starts a reaction. And for everything that's added, there's a reaction, and then there may be a reaction to that reaction, and it just starts a ball rolling to where you think you're fixing one problem, but you're creating more and more problems down the road. And the answer to all of these problems in commercial agriculture has been more chemicals. So we've got a plant that's highly dependent on a high nitrogen source. And because it's growing with an artificial high nitrogen source, it's not growing in the same way that it would in nature, maybe growing too fast. And as a result, leaves it weak. It doesn't have its natural defenses against other problems like insects and disease. So now we got a plant that is susceptible to attack by insects. And now it's being preyed upon by the insects. And then the answer is, oh, we need to treat the insects. So now we spray another chemical to kill these insects. And in doing so, we may be killing other good insects and not realizing, that these insects that we've killed are no longer pollinating our plants. And it just starts creating more and more problems. If we address the soil to begin with, naturally, we'll have healthier plants that are more resistant to disease and less attracted to insects. We'll go on and on. I could talk about that for days, but I'm going to get to that here in a minute.
Greg, we have one question in the chat.
Yep.
Would you recommend a natural product for spreading around the base of a young tree?
I would, and in using compost would be the best recommendation, whether you're getting a compost from a local garden center, not so much some of the bigger commercial garden centers, but more of your local, more organic centered garden centers may have options for naturally, produced compost locally. A local source is always going to be best because it's going to have all of your local native microbes working on that decomposition process. So there's something to be said for the when we talked about native plants, one thought is plant native species in native spaces, but this is also true of our compost and fertilizer products and beneficial microbes, is that if all of these sources are coming from our local, as it were, they're going to be more adapted to our local soil and our local plants and are going to provide much more benefits in the long run. Hopefully that makes sense. But even just using bagged composted manure, something like black cow, is still better than using chemical fertilizers. Otherwise, I'm a big fan of leaf mulch, which you can typically get from the local landfills. They're all being collected off the streets in the fall, and they chew them up all real good. And that leaf mulch breaks down extremely fast. I mean, you could apply leaf mulch to your landscape 4 times a year and never have too much building up because it'll decompose so fast that your plants will get exactly what they need. I'll also talk about the chemistry versus the biology here. What we know is that the biology in the soil is what's critical. What you can see in that person's hand there is what looks like pretty healthy soil. There's a mix of all kinds of things. One thing I'll tell you, if you dig in your soil and you find earthworms, that's a pretty good indicator that you have healthy soil and a healthy soil food web, because the earthworms are relatively high on the food chain in the soil, and they pretty much will not exist unless everything else in the soil is in balance. And so when you're digging in your soil and if you're finding really fine little hair-like feeder roots, if you're finding mycelium and fungi, and you're finding grubs and beetles and earthworms, well, you got a pretty good chance you're dealing with some really healthy soil there. If you start adding chemicals to your soil, all that stuff is going to disappear. And for a long time, again, back to commercial agriculture and the chemical industries, people have always focused for the last 50 or more years on soil chemistry. We talk about NPK fertilizers. So if you had a bag of 10-10-10 fertilizer, the 10s represent the three components of that fertilizer: nitrogen, phosphorus, and potassium. Well, the truth is that in a healthy soil, that is actually irrelevant. And soil pH is also quite irrelevant, in that if the soil is healthy and is full of microbes, it will have everything it needs. In a teaspoon of healthy soil, if you looked at under the microscope, you will find more microorganisms in that 1 teaspoon of healthy soil than there are people here in the United States. It's just phenomenal. And in nature, everything just works out its own natural balance, if everything is healthy, as it is in the forest soil. But again, if we start adding chemicals, all of that changes. And I'll go back to the pH. A healthy tree, if it requires a particular soil pH to be at its optimum health, through the exchanges between the tree and its roots and the microbes in the soil, those organisms will work together and will buffer the soil and alter the pH in the soil over time to a point where it's just exactly what that tree needs. And so there's no need to try to modify the soil pH through the use of chemicals. You start adding chemicals, again, starts that chain reaction of reactions that just makes things worse and worse. So if you wanted to lower, say, a soil pH because you have a plant that's more acid loving, and you're going to use sulfur to do that, well, sulfur is a natural fungicide, and it will essentially kill many beneficial fungi in the soil and could create all kinds of problems down the road. The opposite is true with lime. If you're trying to raise the soil pH to make it more alkaline, not as bad so much with lime as it is with sulfur, but can also cause problems, because it'll leach and may affect some other plants that don't want such an alkaline soil.
Craig, quick question.
Yep.
Are frogs and toads also a good indicator of good health?
They are indeed, because they've got to be feeding on something, and so if in my opinion, and it's more than just an opinion, but wildlife in general is a good indicator of a healthy ecosystem, because everybody's got to eat. And it starts with the smallest of microscopic organisms all the way up through the vertebrates, and be it humans at the top of the food chain, that the presence of any wildlife is proof positive that there's balance, and balance is the key to everything.
Here in the forest, the soil has everything it needs. And because of that, it can take care of the trees. It feeds this oak here, and this thing is super happy. Here's the kicker. Each year, this oak drops these leaves. This rotting stuff, this is soil food. And if we have this, we also have air and we have water. This is what keeps soil alive. I'm Basil, and today I'm here to talk about soil. It is alive, and I mean it's like really alive. It's like you and me. It needs oxygen, it needs water, it needs food. If it has these things, it's gonna feed your trees, it's gonna take care of your trees, they're gonna be healthy, they're gonna be happy. If it doesn't have these things, then you get this. This is what used to be a really beautiful old oak tree, and it is suffering right now. It's a sick tree, and let me show you why. Check this out. So I'm gonna use this screwdriver and I'm gonna try to push it into the ground. I want you to see how much I struggled to get this thing in. We're talking, oh my goodness, maybe 2 inches, if I'm lucky. That's definitely not full of air. You can just see this stuff. There's no water. And let me see if there's anything in here that looks like rotting food for soil. No, it's just more of the same. It's dry, it's super hard. There's no rotting stuff in here. This is sick dirt, which means we have a sick tree. Here's the exciting news. We can resurrect this dead dirt and turn it back into healthy soil by replicating what we see in the forest every day. So here I recommend that we put down lots and lots of wood chips, and then we let the leaves fall and rot every single year. That's gonna create this amazingness that's full of air and water and giving the soil that rotting stuff it needs to eat. That means we've got healthy, happy soil that can then feed the trees. Now we have healthy, happy trees. It's a win-win. And the best part is this. If we do this on a large scale, then we can restore the health of this planet that we call home.
So this is an interesting topic here. We're talking about proper pruning cuts. And hopefully everyone can see in that picture where the handsaw is, where that cut is being made. That is at the outside of what is called the branch collar. The branch collar is very much like the root collar in that it's a transition zone in between the trunk of the tree and the branches. And it's basically where the trunk becomes branch and the branch becomes trunk. This is interesting because this is actually relatively new science. Dr. Alex Shigo first presented a theory of what he called CODIT, C-O-D-I-T, which is compartmentalization of decay in trees. And this theory and his research really came about in the 1970s, which, is relatively recent, considering that trees have been around since long before humans. And it took us that long to find out something that's really, really important, is that the trees possess the ability to wall off wounds and keep decay out, and hence the name compartmentalization of decay in trees. And the ability for a tree to do this is at its highest right in that area, that transition zone of the branch collar. And when a pruning cut is made at the right place, right outside of that branch collar, it stimulates the tree to start producing 4 cell walls that will essentially stop the spread of decay inward, outward, upward, and downward within the tree from that wound. And go ahead to one slide here, which shows you a little bit better of where that collar is. In between the branch and the trunk there, you can see that branch bark ridge. And if you go outside today and look at any tree and look at the branches and the trunks and look for that branch bark ridge, you'll see exactly what we're talking about here. And ideally, a proper pruning cut is made at about a 45-degree angle off of that branch bark ridge. So if you use the bark ridge as one line and made a 90-degree angle from that, and then essentially bisect that, that would be the ideal range of a proper pruning cut. You'll also see that that will be at the outside of that taper between the trunk and the branch, where it starts to become more of the branch diameter. When a proper pruning cut is made, the cut itself will end up looking more round and less oval or anything other than round. On the left side of this photo, you can see the dead branch, and you can see where the tree is naturally making a collar and or its final pruning cut. This is what happens in the forest. And so if you're removing a dead branch, you'd want to cut the dead branch itself and not get into that tissue that's still alive there in the collar. And in nature, this process is called collaptosis, which is kind of a complex process that happens in trees. It has to do with it shedding inefficient growth, but it also has to do with shedding its old leaves. But trees will naturally shed inefficient growth, the parts of the tree that are getting the least amount of light. You can see this in pine trees. As they grow upward, the first live branches get higher and higher as the tree gets older and older, because it's constantly shedding the lower inefficient growth. And gravity works on those, branches break off, and eventually the tree inside the tree starts a process of compartmentalization, which walls off and keeps decay out. Prior to Alex Shigo's research and this theory of coated, people used to make collar cuts. They would cut the tree more in line with the trunk of the tree. They would paint wounds with tree paint or pruning sealants, as they're called. These materials are still available. You can find them in your garden center today. But all of his research showed that, one, these materials are not necessary, and two, they actually can inhibit the plant's ability to compartmentalize against decay and interfere with the tree growing new cells over that old wound. There's a lot of books out there. Cass Turnbull has a book called, or had a, she's no longer with us, but the ABCs of pruning, the hows, when, and whys of pruning trees and shrubs. That's a really good book that tells you, one, why you should prune, and then how to prune. Let me go on to the next slide. So to the whys of pruning, whenever you prune, you should always have a goal in mind. And if your goal is simply to prune it for beauty, for its shape, well, at least you have a goal. People always ask us about crepe myrtles, and as we like to call it, crepe murder. And a lot of times people want to prune just because they think that they have to. They see their neighbors committing crepe murder and think, oh, well, that needs to be done. And so they just are pruning for no other reason other than they think it should be done. I would approach this from a completely different aspect, in that it really starts at the time of planting. That if we plant the right tree in the right place, pruning may not be necessary at all. But if there's dead and decay or defective branches in a tree, that's a good reason to prune. If we've got highly susceptible species, highly susceptible to disease, pruning to improve light penetration and air circulation could reduce the amount of infection within a given tree. So there's a good reason to prune. But most importantly, structure would be the reason to prune, to encourage good, strong, healthy growth within the tree. And I'm going to show you another video. And I think this is going to be my last video for the day.
Here in the forest, trees compete for sunlight. And this means they grow tall, strong, and straight. But if left on their own, like this elm tree here, they often overgrow and end up hurting themselves in the long run. The answer is structural pruning. Hi, I'm Basil, and today we're talking about why we prune. It's the competition here in this forest that forces these trees to grow straight and tall. You'll notice they all have this general structure. They have a central, straight trunk and well-balanced branches. This is really important for a tree. It's this ideal structure that helps keep them healthy and prevent breaking. Structure is strength. If we take away the forest, then all of a sudden this lone tree has all of the sunlight it could possibly want. And that means it's going to grow every which way, and it loses that really important structure that we saw in the forest. So I'll show you a couple of examples here on this elm tree. First of all, you'll notice that it has two trunks. And between these two trunks, it has this seam. This is something that could very easily separate in a windstorm, especially as the tree gets older. And then if we look up in the canopy, we see all these large, overextended branches. It lacks the structure that we saw in the forest. And unfortunately for this tree, that means that it could split. If that happens, it could cause damage to property, it could hurt somebody, and it would almost certainly be the end of this tree's life. The solution is structural pruning, and ideally that begins with a young tree like this oak. But it's important for older trees as well. The idea is that we remove branches to create the structure we're looking for. The process takes many, many years because we can only remove so many branches at any given time. But when it's done, hopefully we've created a tree that looks much like the ones we saw in the forest. That means a straight central trunk and well-spaced branches. For us to live side by side with trees in our neighborhoods means that structural pruning is really important. It helps keep trees healthy, prevents them from breaking, and it keeps us safe. And with all the serious issues that are facing our planet today, we need as many healthy trees as we can get.
And this comes back to, this is relatively new science, as opposed, kind of like what I was talking about with Alex Shigo and compartmentalization. Shigo's research, came out in the 1970s. When I started in this industry 32 years ago, we used to have standards for pruning. They were class 1, class 2, class 3, wherein a class 1 pruning was more of a fine pruning and a thinning and had to do with aesthetics and light and air circulation. A lot of folks over thin trees by those standards. A class 2 might have been just dead branches. I can't even remember what they were. But nowadays we focus more on structure. And a fellow, Ed Gilman out of the University of Florida, has put together some great research and some recommendations for this. And basically, the theory is the best time to actually start pruning trees, maybe at the time of planting. But I'll go back to the crown to trunk ratio that says we need live growth relative to the size of the plant. When we plant a tree, the tree needs to be producing energy through photosynthesis in order to establish its roots. So we would not want to take too much live growth off of it, but let's say we have a new young tree and it has what we call a codominant stem, where two stems are going to compete for dominance in that tree, making a fork in the middle of the tree that over time is going to become more and more weak and may be a real structural defect and could be an issue for safety and or safety for the tree itself at time of maturity. Well, the best time to prune that out is when we can do it with hand snips when the tree is young. And so we basically prune the tree as it grows from the time it's very small, and be it every year, every 2 years, every 5 years, throughout the entire life of the tree. If we prune it on a regular basis to encourage good structure, it'll actually make the tree safer, and it'll also save money in the long run because we're never doing too much at once. So just like with the chemical fertilizers, pesticides, always avoid using pesticides in general, and especially what we call a broad spectrum pesticide. Something that says it's insect killer. Yeah, it's an insect killer, and it's going to kill all the insects, including your bees and all your beneficial insects that in nature are going to control the damaging pests. And that, again, you start adding chemicals, starts a chain reaction, and we have more and more problems. The key to managing a damaging pest is identifying that pest. If you know you've got southern pine beetles in your pine trees, well, then we need to control the southern pine beetles. A pest that's a real concern in the area right now is emerald ash borer. We only have one method we have several methods, but the only way to treat them presently is by using pesticides, but that should be targeted specifically towards that specific pest so as not to upset the balance in nature. And when it comes to insects and even disease, is some damage is normal. And we talk about thresholds. We have to understand, yes, there's a bug that's chewing on the leaves of my cherry tree, but how long is that bug around for? How much damage is he causing? Is it actually affecting the health of my plant? A lot of times there's pests that will damage plants, but it may only be aesthetic. It may not be damaging the tree's health whatsoever. While they may be nibbling on the outer margins of the leaf, they may only be feeding on about 10% of the leaf surface, and the leaf may continue to carry on photosynthesis and continue to make energy, thus contributing to the health of the tree. It's really about understanding balance in nature and thresholds. All right, now we come full circle. And I've said this before through the presentation, and I'll always go back to this, is when in doubt, look to the forest. In the forest, nobody's raking the leaves, nobody's fertilizing the trees, nobody's spraying for insects, nobody's spraying for weeds, nobody's spraying for disease. And there's because there's no need, and because they're leaving the leaves and everything is decomposing and feeding the soil, and it's all about the biology in the soil. When the soil is healthy, the trees are healthy. And when the trees are healthy, they're less attractive to pests and they're more resistant to disease. And I'm going to leave this up here for a minute. There's my email address. Anyone, please, feel free to take that down. You can reach out to me with any questions. I'm happy to answer them at any point in time. And I'd mentioned earlier that I'm a tree ecologist. If you go to our company's website and search Treecologist, we have a course, Treecologist 101, where basically we'll send you monthly newsletters with lots of great educational information in there, basically arm you to be educated about trees enough that you can talk to friends, family, and neighbors in general about trees. And we even certify you as a tree ecologist at the end of the course. And they're just little monthly newsletters that include videos and articles. But at the very end, we send you a t-shirt, and people love our t-shirts. And but what we really do is we give you some really good free educational material.